All right, so chapter 14, section 4, moving right along. We're going to be looking at population growth and the patterns that they can make. I want you to be aware that the things that affect population growth most often are immigration, births, emigration, and deaths. Immigration is in, emigration is out, and then births and deaths, or you could think of them as in and out of the population as well. So we have traveling in and out, and then being born and dying as in and out as well. Those are the things that are by far the biggest effectors of population and their growth. You can get something called exponential growth. This example here, they're using rabbits. Bacteria like to do this too. Exponential growth is this maximum growth, unlimited, unstoppable growth that happens. If rabbits or bacteria or anything gets into this exponential growth phase, then their growth is currently not being limited by water or food or mates or shelter or predation, like being eaten and stuff. They can just kind of move on and make babies. Logistical growth is reaching this idea of a carrying capacity. So, as I mentioned before, if exponential growth is having no limits due to all these different limiting characteristics, then logistical growth would be an example of where they are being limited. What sort of things would be limiting them? So lack of water, lack of food, lack of housing, etc., to be able to exist. That would reach a carrying capacity. You can also get a exponential growth and then go into a logistical growth sometimes. That can happen. So carrying capacity is a maximum individuals that can be supported in an environment. And one example of this, well, so you're aware, you reach your carrying capacity when the first limitation is reached. So if every rabbit needs food, shelter, a mate, and water, then the first limit it reaches as the population grows, that will be the carrying capacity. Because you need all those things to survive. That being said, then if you look here, this is a graph showing fish kill events, right? Hang on. There we go. Fish kill events, which are the bars, and rainfall in inches, which is the orange lines. So if you see the rainfall in inches as it goes down, especially here at the end, you see that there's fewer fish kill events. And when the rainfall in inches was higher, the fish kill events were more common. So there is that this suggests that there might be some connection between rainfall and fish kill events. It doesn't prove it, it suggests it. So you'd have to look into why is this happening and go from there. So, density dependent limiting factors are limiting factors that are determined not so much by the number of organisms, but the number of organisms in a given area. Okay, so food is a good density dependent event because there may not be food where you're at, but there'll be food right next door. Uh, shelter, that sort of thing. Predation, competition for food and resources, parasitism and disease. These are all examples of density dependent limiting factors. So here you have an orange line, which is a moose, a teal line, which is a wolf. Now, just so you know, wolves hunt moose and usually in packs. And you can see, as the moose population goes down, the wolf population goes down. As the moose population goes up, the wolf population goes up, and then kind of traps the moose population and shrinks it down. Uh, is it possible for there to be so many wolves that all the moose die? Yes, it's possible, but highly unlikely. Is it possible that there are so many moose that the wolves can eat all they want and never? I guess that is possible, but also highly unlikely. What's more unlikely going to happen is they're going to balance each other out as long as they're capable. And as the moose population goes up, wolf go up. As the moose population goes down, wolf goes down. Density independent, which don't regard a particular area's population, are weather, natural disasters, and human activities. Okay, these are independent of the density, but they are going to limit the growth of that population. And that is it for chapter 14, section 4.